Hello to all. So for our second video, still under the same subtopic 9.1, but now we will discuss or determine the differentiability of a function. So basically, in order to check the differentiability of a function, we have to use the concept of one-sided limit. But for this one, we have a specific formula here where our f prime of a, where a in this case is the value of x that we have to find, is limit of x approaches a from left must be equal to limit of x approaches a from right of fx minus fa divided by x minus a. If we get the same value for both limit, it means that our function can be differentiated. But if it's the other way around, it means that our functions are not differentiable. So let's do some example to check our understanding. So for example 3, we have to show that our fx here in this concept of piecewise is differentiable at x equal to 1. Okay, so here for x equal to 1, it means that now our value of a is 1. So I just redraw back our piecewise function in the sense of number line. So first one, if our x is less than 1, so our function here will be x squared plus 1. And if our function is at least 1, then the function will be 2x. Okay, so using the concept of one-sided limit in order to check their differentiability, our first one for this one is f prime of 1 for limit of x approaches 1 from left. I check from the left side first. Then our function would be fx minus fa over x minus a. So for 1 from left, based on the number line, our function would be x squared plus 1 minus fa means we have to substitute the value of a into our function. So here we will get 1 squared plus 1 divided by x minus a. So in this case is x minus 1. Now we have to solve this by using the concept of limit. So this would be equal to limit of x approaches 1 from left of x squared minus 1 over x minus 1. If we try to substitute x approaches 1 here, you will get 0 over 0 indeterminate cases. But then we can identify that we have a quadratic function there, so that function can be factorized. So x squared minus 1 can be factorized as x minus 1 x plus 1, and after we factorize that out, obviously you can see that you can cancel out the factor of x minus 1. So substitute the limit once again, you will get 2 as your answer. So this is for 1 from left. Now we have to check for 1 from right. So limit of x approaches 1 from right of our function here, 1 from right would be 2x minus with 2 times 1, you're going to get 2 divided by x minus 1. Okay, so here if we substitute once again, you're going to get you're gonna get 0 over 0, but then you can see that basically we can factorize 2 outside. So limit of x approaches 1 from right would be equal to 2 of x minus 1 divided by x minus 1, and once again x minus 1 can be cancelled out and our final answer would be 2. Since we get the same value for 1 from left and 1 from right, we can conclude that basically our fx is differentiable at x equal to 1. Always remember that whenever you have a show question, you must have a conclusion as the last step of your calculation. Okay, now part B. Given we have f(x) equal to absolute value of x minus 3, and we have to identify whether f(x) is differentiable at x equal to 3. So the tricky part here is basically we have an absolute function here. So whenever you have an absolute function, you have to define first your function. So our function would be positive of x minus 3 whenever we have x at least 3, and we will have negative of x minus 3 for x less than 3. And that is our piecewise function. And if we draw this on a number line, so for left side we will have negative of x minus 3, and for our right side we will have x minus 3. So here would be 3 from the right side, and here would be 3 from the left side. So in order to answer the question, we have to check the limit. So limit of x approaches 3 from left first. So our function 3 from left would be negative of x minus 3. Minus with substitute value into your function. So you're gonna get 0 divided by x minus 3. Here x minus 3 can be cancelled out, and your final answer would be negative 1. Now we check from the right side, so we will have limit of x approaches 3 from right of x minus 3 minus with once again 0 divided by x minus 3. So x minus 3 can be cancelled out, and our final answer here will be 1. Since we get a different answer for 3 from left and 3 from right, we can conclude that basically our f(x) is not differentiable at x equal to 3. Okay, so proceed to example 4. We have to show that f(x) equal to absolute value of x cubed minus 27 is continuous. Continuity you already learned in topic 8, but not differentiable. This is what you have learned before, at x equal to 3. So first we answer the continuous part. Okay, So before we begin our solution, so make sure first you have to define your function. So x minus 27 in the form of absolute value can be defined as positive of x cubed minus 27 for x at least 3, and we will have negative of x cubed minus 27 for x less than 3. So in order to check whether the function is continuous or discontinuous, we have to perform 3 tests. So our first test is to check whether our f(3) is defined. So here, if we find f(3), we will get 3 cubed minus 27, and you will get 0 as your final answer. So we have a defined value here. So we pass the first test. Now for second test, we have to find whether the limit exists or not. So first one, we have to perform one-sided limit test. Limit of x approaches 3 from left, in this case would be negative of x cubed minus 27. Here we will get 0. And limit of x approaches 3 from right of x cubed minus 27, you will also get a value of 0. So we can conclude that basically limit of x approaches 3 of f(x) would be equal to 0, means that our limit here is basically exists. So we pass our second test, and for our third test, we just basically have to check whether our answer from the first test is equal to our answer for the second test. And in this case, yes, our F3 value is equal to our limit value. In this case, it will be 0. So since we pass all three tests, we can conclude that our fx is continuous at x equal to 3. Okay, so now we are done with a first question. Let's proceed with the second part. We have to show that our function is not differentiable. Okay, so if we want to check the differentiability, we still have to find the one-sided limit using the concept or formula of differentiable. So first one, we have to find limit of x approaches 3 from left of fx. So for 3 from left, our function would be negative of x cubed minus 27 minus with our fa. So if we substitute 3 here, you're gonna get 0 divided by x minus a. Okay, now if we use the concept of limit, once I substitute here, I will get 0 over 0, where we will get an indeterminate case. So you have to factorize this out, but then we have a cubic function here. So in order to factorize a cubic function, you have to use your knowledge from chapter 2, where you have to perform long division. Interesting, right? We have to connect our knowledge from previous topic. So for our long division here, first part you have to multiply with x squared. So we're gonna get x cubed minus 3x squared. So our function would be 3x squared. Now for the second value, we can multiply this with 3x. So we're gonna get 3x squared minus 9x. Once you subtract this out, you're gonna get 9x minus 27. And for our last part, we can multiply this with 9. So you're gonna get 9x minus 27. So you don't have any other remainder, means that you successfully factorize the equation out. So our function now will be negative of x minus 3 times with x squared plus 3x plus 9 divided by x minus 3. And obviously there you can cancel out the factor of x minus 3. So substitute limit of x approaches 3 into your function. So you're gonna get negative of 3 squared plus with 3 times 3 plus 9. So your final answer in this case would be negative 27. Okay, so that is for limit approaches 3 from left. Now we check limit of x approaches 3 from right. So our function would be x cubed minus 27 minus with, in this case, still the same, 0 divided by x minus 3. Once again, we encounter the same functions. So means that using the same long division part, we can factorize this out as x minus 3 times with x squared plus 3x plus 9 divided by x minus 3. So now we can cancel out the factor of x minus 3. And last part, substitute your limit value into your function. So we will have 3 squared plus 3 times 3 plus 9. So your final answer here in this case would be 27. So obviously then now we can see that we get a different answer for both one-sided limit. Limit of x approaches 3 from left, you're gonna get negative 27, while for limit of x approaches 3 from right, you get 27. So our final conclusion here is fx is not differentiable at x equal to 3.